Hello there, this is Teacher Mark, and today in Exponents, Indices, and Roots we have Part 2. In Part 2, we're going to see some additional rules for indices and review what we've seen already, and we're going to see examples of all the rules. So let's get started with that right now. Okay, before we get started on the new material, let's have a brief review. So in the first one we saw if we had something like a to the power of n, that a is called the base, and n is called the exponent, or power, or sometimes it's called the index. Alright, we saw some rules. We saw the basic rules of a to the power of 0 is equal to 1 for a not equal to 0. And we saw that a to the power of 1 is just a. We saw that a to the power of n times a to the power of m, that we add the exponents together, n plus m. We saw that a to the power of n raised to a power inside parentheses or brackets becomes a to the power of n times m. Okay, and we also saw that a to the power of negative 1 becomes 1 over a, and in fact a to the power of negative n becomes 1 over a to the power of n for n greater than 0. Okay, so after that very brief review, let's go to the new material. Okay, so the first thing is fractional or fraction powers or exponents. And so this is what this looks like. We'll start with the very basic one, a to a power of a unit fraction, 1 over n, for n greater than 0. Okay, that this is equal to what you've probably seen before, the square root symbol, with n here indicating which root it is, and a. In other words, for example, a to the power of 1/2 is equal to the square root of a, which we can write with a 2, or normally we just write as that, without leaving the 2 off as the default. So we could see an example of that. For example, 16 to the power of 1/2 is 4. 64 to the power of 1/2 is 8. 9 to the power of 1/2 is 3. Okay, but it's not only just 1/2. We could also have something like 1/3. For example, 64 to the power of 1/3 would be the cube root of 64, which is 4. Or 1000 to the power of 1/3 is 10. Okay. As well as 27 to the power of 1/3 being 3. Next, we can see how the part with 1/2 and 1/3, it fits together with the other rules we've seen. For example, if we have 64 to the power of 1/2, well, you might know that 64 is 8 power 2. And I pick 8 power 2 because this gives me a power inside of power 2, and this is about 1/2 with a 2 in the bottom of the fractional exponent. And so this means we know that this is the same as 8 of 2, power 2, times 1 over 2, which is 8 of 2 over 1 times 1 over 2, and then we can see the 2's cut, and then our answer is just 8. So in other words, 64 to the power of 1/2 is just 8, as we knew. The same thing for something like 27. So 27 to the power of 1/3. We might know that 27 can be written as 3 power 3, and then that would be to 1/3. So that will become 3 to the power of 3 over 1 times 1/3, with the 1 and 3's cutting, and then that leaves us with just 3. So 27 to the power of 1/3, or the cube root of 27, is just 3. Alright, let's go on to the next thing. Well, rather than just have only the unit fraction being a 1 over some number, we can also have fractions where there's two different numbers like n and m. And so a to the power of n over m, This is equal to the mth root of a to the power of n. But it's important to also see that this is equal to the mth root of a and then that to the power of n. And this second form is often much easier to work with. So, for example, if you had something like 125 to the power of 2/3. Well, one way to write this would be the cube root of 125 squared. Well, I think nobody really wants to take 125 and raise it to the power of 2 and then try to take a cube root of that. However, if we start the other way, so we have the cube root of 125 and then the answer to that squared, we can see the cube root to 125 is 5, right? Because 5 power 3 is 125. And so 5 squared is 25. And so the final answer to 125 to the 2/3 is 25. Now, another kind of problem where we could see this fraction notation come in handy is perhaps if you had this, the square root of 16 x power 8 y power 2. Alright, so this could be rewritten as a bracket 16 x power 8 y power 2 all to the power of 1/2. 1/2 power being the same as square root. And from this we can start to manipulate it. We could rewrite 16 as 4 power 2. 4 power 2 because we want to make power 2 so that it's equal to or a multiple of the base of the fraction exponent outside. And then we have x power 8 and y power 2 to the power of 1/2. And now, following the rules here, we can distribute the 1/2 exponent to everything inside. And so basically we get 4 to the power of 2 over 1 times the 1/2. 8 to the x to the power of 8 over 1 times 1/2, and then y to the power of 2 over 1 to the times 1/2. And this we can see here, the 2's will cancel, giving us 4 just to power 1. The 8 and the 2 cancel, giving us x power 4. And the 2's and the 2's cancel here, giving us just a y. And so the answer at the end is 4x to the power 4 y. Now we can come up with another kind of question that's like this. Suppose we have 64 and we want to find the cube root of 64, and let's say we don't know the answer to that. So I'll rewrite this as 64 to the power of 1/3. And now, starting from this, I'll use my rules of exponents to manipulate this further and say, well, 64, I know that 64 is really 8 times 8. And so this can distribute now, so I know 8 to the power of 1/3 times 8 to the power of 1/3. Keeping in mind that power 1/3 means the cube root, so the cube root of 8 we know is 2, right? The cube root of 8 is 2. So we get 2 here, and then also a 2 here. So in the end, we get 2 times 2, which is 4. And so the answer, the cube root of 64, is 4. And so we can rewrite things to get answers like this. Okay, and we can also have a problem like this. We could have a fraction inside, like 8 over 27 to the power of 2/3. Well, this says, first of all, we probably want to take the cube root of the inside. So cube root of 8 over cube root of 27, and that whole thing will be raised to the power of 2 at the end. Well, we know the cube root of 8 is 2, and the cube root of 27 is 3. Then to the power 2 means we have 2 power 2 over 3 power 2, or in other words, 4 9ths, 4 over 9. So 8 8 over 27 to the power of 2/3 becomes 4 over 9. Okay, that's it for this video. Come again next time and we'll see some more about exponents and roots. Remember to subscribe to my channel, like this video, tell your friends about this video, and you can find me on Twitter where there will be announcements of new videos as I publish them. So thank you very much, and we'll see you soon. Bye-bye.